Sir, we are live now. Please start.
Good evening to all. Myself, Swaminathan, Additional Chief Manager, NLC India Limited, Neyveli. Our core business is power generation and pitted mines. Our plant is a pitted power plant. Our mines means normally people will think that normally know about the underground mines. People, whenever we are talking about mines, means immediately people will imagine the underground mines. But our mines is something different. It is called Opencast Mines. So Opencast Mines is something different than the traditional underground mines. Just if you want to assume, I am unable to understand what is the Opencast Mine. Just it is something like a pond. If it is something like an open pond, if you see an open pond, how it will look like? The same way, the mines also look like an open pond, but the size will be big. Big in the sense, length will be around 6 kilometers, width maybe around 6 kilometers. The total area may be enormously high. We can't imagine such a big mines. So we are one among the biggest mines in Asia. So our mining technology itself, it is a highly sophisticated mining technology. We are using specialized mining equipments in our area. So those machines are highly costly. Every machine is something like a ship. So whenever we are talking about mining equipments, immediately in our mind, and the dozers, dumpers will come into our picture. So it will something to look in terms of crores, right? But our Opencast Mines SME machines are cost around 150 crores. Every machine is more than 17 crores. So adopting IoT technology in those machines, we are going to discuss on today. Before starting the topic, we want to know why we need to adopt this IoT technology to those machines, right? That is a basic question, because nowadays all people are talking about IoT. We are adopting IoT in plenty of areas, right? But why all people are very curious in IoT technology? So is it just for time pass? No, it is not for time pass. Exactly speaking, business. The invention is only for the business, making the business. If the business is profitable, then only the invention will be most useful to all the people. So from business point of view, all people are having attention on the IoT. How? Right? This is the how. The question will be that. For business leaders, always they will think on what will be the next trendsetter, what will be the next market major player, what will be the next market attention. So this is always question in front of all the business leaders, right? So the business leaders wants to predict the next day market, right? So in the same way, if we are trying to predict the next market, it indirectly shows IoT is the next trendsetter. How we are evaluating how the IoT will be the next trendsetter in the market? It is a very simple thing. We all know that during 1960s to 1980s, mainframe computers, right? Mainframe computers are major invention in those times. Major inventions, and they played a lot in the market. The same way, if we go to 1980s to 1990s, number of mini computers, right? Number of mini computers, that invention and its population was enormously high compared to mainframe systems. If we compare the population of mainframe and the population of mini computers, the mini computers population was approximately 10 times of the mainframe computers, which was captured during 1960s. So if anyone predicted during 1980s, mini computer will be the next trendsetter, if those companies or leaders try to invent or market mini computers, they will be the leaders during 1980s to 1990s. right? So that's the thing. But after 1980 only we came to know that my mini computer is a major dominant in this field. The same way during 1990s, the PCs, personal computers, become the market leader. So they are the dominant. Once again, during this session also, if you closely observe the population of personal computers, well, 10 times the mini computers population. So that's a potential of the market. So in the same way, if you go to 2000 to 2010, the major thing is desktop computers, internet. Many of the desktops are provided with internet systems. So all the applications activities started to happen based on the desktop internet. So the same way, this time also, the same statistics was observed. The population of internet, desktop internet is 10 times the number of PCs population. So next thing, the mobile internet. So if people approximately, if the people in the age of 40, they can accept the PCs development and desktop internet development and mobile internet development, those things. They maybe visualize all these things in their lifetime, right? So now, up to 2020, in the mobiles, all mobiles are provided with internet. So if you are, this mobile internet also become 10 times the number of desktop population. If we are unable to accept this point, just we can see some of the events which has happened in last 2 to 3 years. And during 2010, we seen Android or smartphones, right? By around 2016, so 16, 17 or 18, we started to see about 4G networks. I think we've seen some of the networks provided 4G free of cost. So many people started to use 4G internets, right? Now it become a common thing to all the people. Now all the people are having smartphones. Most of the people are having 4G connections. So if you totally see all these things, everything become 10 times manifolded. So now 2020 is ready. Our question in front of us is, what will be the 2021 to 2030, right? If we predicted, if we invested our time in that field, we can be the dominant in the next 10 years. That is the issue for the business leaders. So obviously the result is the IoT. Why IoT? How they predict the IoT? So once again, the potential is 10 times the mobile networks connections. That will be the population what we are expecting for IoT, right? So how they identified IoT will dominate in the next 10 years. Not only next 10 years, it will go up to 30 years also maybe. That may be also possible. Because we are having some expectations, we are having, especially mining fields, are having some plans up to 2050, right? So how they identified IoT will be the next 2020 to 2030. Yes, for that one, we need to study about Industry 4.0 revolution. What is the Industry 4.0? What is going to happen in the Industry 4.0? What are the things is going to dominate in the Industry 4.0? Why we need to prepare for Industry 4.0, right? Before that, we come across 2.0, 3.0, like those things. When the steam turbine was invented, that time when the industrial revolution happened, those time when the electrical motor was invented, that time next industrial revolutions happened. When the computers was invented, when the networking was invented, those times further industrial revolutions what happened. But in all the revolutions, only one thing is common: the companies which were prepared, which were already prepared for the revolution, and the companies which adopted for the revolution only sustained after the revolution. The remaining companies are unable to survive after the revolution. So that is the business leaders' issue. Now Industry 4.0 is going to happen. If it happened after that, if they were prepared for this revolution, then only their business will be sustained in the next era. Otherwise, there may not be. The threat is there for the leaders. So Industry 4.0. So now the time to think about what is the Industry 4.0. Industry 4.0 focus on what? Industry 4.0 focus on only IoTs, IoT technology. It is completely focusing on IoT technology. So in all business, even it may be a taxi business, even it may be a retail business, even it may be a medical business, whatever may be the business, in all business, all people are thinking about how the IoT is going to change the business. The same way, we are also giving attention how the IoT is going to change our business methodology. That is our mining business methodology. That is the thing. That's why this is our interest. That's why we are working on this project. Right. Next. In today's session, we will go through basic overview about IoT. That is our first session. So we will go through what is the basic of IoT. Even if we don't know the basics of IoT, we can easily come up with this presentation. No issues in this. The second topic we will focus on historical perspective of IoT and its business potential, the quantum of business potential involved in IoT, right? So that too also important. So when we are talking about, we are having some milestones, already pre-filled milestones. 2050, not only ours, all the mines are having some milestones. What are the development to be there in the mines after 2050? So that also mainly depends on the IoT. All of the milestones are based on IoT's growth in the mines and the mining equipments. So next thing is, when we try to execute the project in our mines, what are the challenges we faced? Actually, we started this project in 2016 only, but we are in the same similar projects from 2008 onwards. So today we are going to discuss, if we try to adopt this type of technology in Opencast Mines, what are the issues will come, and finally we also will discuss about what are the solutions also will solve these issues in upcoming future, right? That also we will discuss based on the project experience, right? These are the major 4 topics today we are going to cover, right? Now, the first topic is what are the basic components of IoT? Very simple question, a basic question in front of us. For a beginner, it is a simple. For IoT means, first what we want? We need internet. As the name says, Internet of Things. First, we need internet. Without internet, IoT project cannot be executed. That is a major challenge in front of us. We need internet. The second thing what we need is, whatever may be the system. The system may be a washing machine. A system may be a dishwasher. A system may be a iron box. A system may be a car. A system may be a bike. A system may be a TV. A system may be a AC. Whatever may be the system. But that system should have data connectivity facility. What is meant by data connectivity? Simply, if you want to say, it should be a digital device. Even, for example, if we are using a car may be a mechanical device, but the control system is a digital device. It is having some microprocessor. That microprocessor should be capable to communicate with us. That way, that's the thing we are telling now. Systems with data connectivity facility only can be connected for IoT. Right? This is a major challenge for industries. Why? We will discuss. Then, after having internet, after having a systems with the data connectivity facility, next thing is storing the data. Where we can store the data? Predominantly, it is a hard disk, right? We normally we call it as, in technical word, we will call it as a server room. We need a server room. The simplest way, if you want to understand, if for a beginner, if I don't know what is meant by server room, if you said it is simple, it is something like a hard disk, right? It is a hard disk, right? we need a server room or servers, right? So after having all these three, next thing, the data capturing, data transfer, all these things can happen with the human intervention or without human intervention. Both is possible. We can do with the human intervention, without human intervention also. So where the human intervention is there, it will be in the control rooms. So in this project, we also have, in the mining projects also, we also have some control rooms. From the control room, we will try to control the equipments. So the data transfer, sometimes the data transfer will happen automatically, once in a minute it will happen. Sometimes when we initiate the data transfer, that time also it will happen. So both is possible, both may happen. Then, so finally, what is the ultimate result of the IoT project? We have systems with data connectivity, we have internet, so systems are connected through IoT. So now the system's data is captured, it is stored in the server room. In the same server room, the data are being processed and they are consolidated in a manner how the end user wants. Probably end user is a human being. So how I will expect the results? Predominantly, we will expect the results in the form of tables, graphs, bar charts, pie charts, in this manner only. Predominantly in pictorial format, we will expect all the results. That will be very easy for the human being to understand. We are not the machines to give all the raw data as it is, giving 10,000 numerical values. It is not like that. If we are having 10,000 numerical values, instead of giving the values as it is, if you plotted a graph, then it will be very easy for us to understand. If you are unable to accept this point, very simple. If you want to analyze our senses, how we are always analyzing senses? Simply by using graphs, right? The same way, the servers analyzes the data and process the data, gives the results as per our need. Those data are shared with the people whomsoever they want, whomsoever they initiate that need, right? The people may be in anywhere in the world, whomsoever and anywhere in the world. For those people, it will be shared. If we need, we can put some security locks also by like something like a login ID and passwords. That's also possible in this one. So, okay, next. So, how to execute the project? How to execute a IoT project? We will see that. So, it will have 5 to 6 steps. The first step is it may be any systems. It may be a car, washing machine, dishwasher, AC, heater, anything can be connected in IoT. So it may be any system. So just for example, only I shown only 3 items. Anything can be connected. So in this one, these equipments should be connected in internet. That is a major thing. For example, if I am having a refrigerator, right? Refrigerator, if I expected that refrigerator should be controlled through IoT, right? Well and good. First thing, how to enable the internet to the refrigerator? The traditional refrigerators are not provided with the internet facility, Wi-Fi facility, anything, nothing will be there. So in such a case, how I can execute a IoT project with such a refrigerators? So the equipment should be designed to connect with internet. If it is so, then it can be controlled through IoT. So nowadays, there is no need to say their names. Many cars are coming with Wi-Fi enabled. That then many washing machine, dishwashers, then air conditioners. Nowadays, geysers too controlled through IoT. Nowadays, EV vehicles, predominantly IoT is being applied in EV vehicles and many areas. So first step is connecting the internet to the devices. This is for BC understanding. I am telling these equipments as an example. But in our projects, for our equipments, the task was very complicated. We will see why it was very complicated for giving internet to the systems. So normally we will think that, sir, have some cell phone, go to the spot, switch on the hotspot. So that's how the system will be connected to internet. That will be our common answer. But in the industry's project, this is a major task in front of us, providing internet and connecting the equipments through internet. Why? We will see. So second thing, collecting the information from the equipments. For example, if it is a car, what are the information we will expect? Whether the car is running, whether the car is idle, whether any service due is there, any malfunction is going on in the car, any all the equipments are working normally. These type of information. Like that. The same way in industries also, we are having plenty of questions. We need to monitor all the equipment. We need to monitor the process. We need to monitor the equipment status. We need to monitor the service schedule of the equipments. And many things we need to monitor in industrial areas. So for all those things, we need to collect the data lively from the equipments. So collecting information from the equipments is the second step for us. Then the third step is connecting billions of equipments. Our aim is not for not connecting one or two or three or four or 100 or like that. In this world, whenever they are talking about IoT project, they are aiming for connecting billions of equipments in the IoT. So it is not only limited to billion, it is going beyond that. So how it is going? It is going for billions and billions of equipments are going to be get connected. It is after connecting all the equipments, they are going to make intelligent systems. How they are going to make the intelligent system? So I am unable to understand it. What is the intelligent system in this? What is the intelligent involved in this? Very simple. A normal example. What we are using daily, we are using it. So we are using some GPS tracking. We are monitoring what is the traffic in the road, right? So sometimes we are the map is showing to us that a particular area is highly crowded. It is gaining us, don't go in this way, you take alternative ways. Is it always there? It is showing that on that area is always traffic is high? No. Based on time, based on the condition, it is giving the information to us. How it gets the information? It collects the information from the spot. It collects information from the spot. It is having some IoT device on the spot. From that spot, it is observes that what is the traffic condition as of now. From the information, it is sharing to me where I am minimum 10 to 15 kilometers away from the spot. It is instructing me to take a diversion, not to go in this area. So this is an intelligent system. So something like this. The same way, for example, in retail market, if I am going to purchase a thing in retail market, for example, it may be a soap, otherwise it may be a medicine, anything. When I am purchasing something, it is showing to me, it will take minimum this much time to get delivered in my area, right? So that is a connecting, that is a connecting billions of equipments together, and then they will start to behave, act as a intelligent systems. They are guiding me. It will take this much time to reach your area from that spot. For example, if it may be a Delhi, for bringing the material from Delhi to here. So now it is showing abnormal time delay, sir. So for you, normally it will take 3 days. Now it will take minimum 5 to 6 days. Better you go for air shipping, right? It is giving me a suggestion also how I can ship. If I am ready for the cost, if I want very urgently, then I will go for air shipping, right? So that's the thing. That's the advantage. That's the power of IoT. That's the thing we are expecting. These things were this retail and taxi business. These things already we've seen the results in the market. How they change the business scenario, right? The same way we are expecting many fields, medical and power generation, many more fields. So after collecting all the equipments together in IoT, we have enormous data. We have enormous data. What to do with the data? Who will take care of the data? Very simple. All the data is stored in server room. Server room, the data will be processed. As we discussed previously, the data will be processed, analyzed, it will be presented as per our expectation. It will be shared to all the people, right? So how it will be shared? It will be shared in the bar graph, pie charts, or otherwise normal charts, anything. In which manner we are expecting, how we design the web page. That is a web page. Normally it is a web page, right? So once again, we want to view because we are planning for up to 2015 by using IoT in mining field. So once again, we want the justification how we are expecting IoT will be the trend changer, right? From communication system point of view, how it is simply very long back, how the communication was happened. There will be a station. If you want to send a message, the information will to come to another station, not to our house, not to our hand, not to our pocket. It will go to some another station. So for youngsters, if they are unable to understand what is meant by station to station communication, very simple. Telegrams, not the Telegram app, the telegrams which we had very long back. Recently, it was, I think it was closed, right? Right. The telegrams. In telegrams, if we want to send a message to my neighbor, to my relative, how I will contact with them? By using a telegram. Father, what I will do? I will go to the post office. In post office, I will fill up some form. I will hand over the form. The person who is there, he will collect it and he will charge some money. Then he will send the message through the telegram machine. That information will be collected in another station. Then they will decode it. Then a man will be there. He will decode the information. Then after decoding the information, he will make a write in a paper. Then he will send the information to the end user. That is my relative. So that time, station to station communication was there. Then the station to station communication was upgraded to station to people communication, right? What is in station to people communication? The easy example is our TV or radio broadcasting. Station is that they are broadcasting, information is reaching all the people. We can sit in our home, we can see, we can get alerted for the cyclones, we can get information regarding budgets immediately after posting the budget. We can get all the news instantly, because previously by seeing the newspapers only people got the news, right? So now the communication was upgraded from station to people. The next upgradation is people to people communication. What is people to people communication? It is very simple, telephone to telephone, right? But the telephone is locked in one place. Now mobile to mobile communications. People are always roaming. Wherever they go, they are holding the mobile phones, right? So the people are able to communicate with each other. But the trend changer is here only. Now no more people are going to communicate with the people. We won't accept equipments are going to talk with another equipments. Missions are going to talk with another missions. India is get prepared for that. Many things came into market for this. The next change will be mission to mission communications. So that is by IoT. Mission won't inform to you. It will straight away will contact its another mission. Whatever the things needs to be done, it will be carried out without your presence, without your knowledge. We can have a comfortable lifestyle. For that, all these things are happening. So if anybody told I can't believe this, very simple thing. We can accept, we know that how it is happening. For example, if you are having a car with an internet facility, some of the cars are having internet facility. So those cars can communicate with the service centers. So if there is a service due for the car, if that is for example, for every 10,000 kilometers, the oil needs to be replaced for every car, right? It is a generalized thing. So if the car kilometer reading is crossed at 10,000, immediately it will send the message to the service center, not to you. The service center representative will wait for 1 or 2 days. Then he will check our car reading. It is possible. He will check our car reading. If it is still it is continuing on the road, then he may contact us. He may remind us, sir, it is a due for a car for servicing, for replacing the oil. Otherwise, they will send you a message, SMS, WhatsApp message. Anything is possible. This is the future. Future will happen in this manner only, right? In this area, if you go and check what will be the future in medical field, it is enormously unimaginable things are going on. So if we had any issue, immediately doctor's appointments also can be fixed by using IoT technology. That is also possible. Where you will have some capsules, that capsules will be always inside our body. It will continuously monitor. That type of R&D is also going on in IoT technology in the medical fields, right? So Regarding the business, so regarding business, what is the potential means? By 2020, number of equipments, as I told, billions and billions of equipments are going to be connected in IoT. So 2020, one of the statistics says it is around 24 billion equipments are connected in IoT. What is a expectation? By 2025, it is expected that can be 41.6 billion equipments. So that much potential is there in this business. So by 2025, 41.6 means by 2030, by 2040, 2050, we can't believe, we can't understand, we can't expect as of now. We can't predict as of now. So, okay, nice. The fields which the areas, technical applications of IoT, medical, transportation, retail, industry, communication, energy, these are the major areas the IoT is having major impact. So we all know that how transportation system, retail systems are changed. Then communication systems also a lot of changes there. In energy market also there will be a change, because nowadays we are going for renewable energy concepts. For renewable energy, wind is a dominant player in renewable energy, right? For wind energy, so those energy availability cannot be predicted like thermal, right? In thermal, we are having full control on the power generation, but thermal energy, it is based on the natural thing, calamities only. In such a things, they are talking about formation of small size grids, and what will be the energy demand instantly, what will be the power generation instantly. All these types of information is required in the future for making that is mini grid systems, micro grid systems. So for such a things, IoT in those areas is a major thing for establishing microgrids, right? So now we are going to discuss how the IoT is adopted in industrial areas, right? For industrial areas, regarding mines, we are having the milestones. As I told, up to 2050, we are having milestones how the IoT projects will rule the mines. So now, as I know, how we are designing our mines. We people are working on the design of mines. So we are having some softwares. By combining together, people and softwares combining together, we are designing the mines. Though these two governs the mines. But by 2030, we are expecting semi-self-governing mines. Semi-self-governing mines. That is what we are expecting. As I know, all the trucks are provided with GPS tracking facilities. So yeah, now it's that we are come across many companies are working on automatic driving technology. So anyway, it will come in some of the years. So what we are expecting by 2030 in mines is automated trucks, truck-to-truck communications. That is semi-self-governing. We call it a semi-self-governing. So party, what we are expecting is the decision will be taken by AI-based systems. In addition to these automated trucks and all these things, this thing also will add up decision making. That is mines design. Mines design will be done by using AI-based systems. So that will be the major milestone for 2040. By around 2050, that is our target. That is virtual mines. Virtual mines means all the decision making and the planning, everything will be done by automatic systems. We will have some IoT based AI systems, artificial intelligence systems. So human being involved in these key areas will be totally minimized. We will involve robots in the mines. So these things will happen by 2050. For the things to happen by 2050, now itself we are working on this, right? So that is a plan for mines. So if we talk about mines, as I said, commonly all people know about underground mines. Underground mines is something like a tunnel, right? Something like a tunnel. We all know that. So today we are discussing about Opencast mines. As I told, it is something like a pond. It will be, and our poster itself, it is very clear. It is something like a pond, right? If we enter into mines, if you see upwards, you can see the sun. So that's called Opencast Mines. So for Opencast Mines, the equipments, what is the mining equipment used? There will be major two categories. One is the CME equipments, conventional mining equipments. Our dozers, dumpers, wall cutters are coming under conventional mining equipments. So next thing is SME equipment, specialized mining equipments. How they are going for CME and SME. If we want to take a huge quantum of material out from the mines, then CME is somewhat better. So based on that only, we are working on CMEs. So in SMEs are better for huge quantum for mine huge quantum of materials. So in SME equipments means SME equipments covers bucket wheel excavators, mobile transfer conveyors, and spreaders. If you search in the internet by using these keywords, we can see plenty of photos how they exactly looks. Actually, we will surprised by seeing those equipment photos because they will look like something gigantic, more than a ship. But a ship will be in the seawater. But these equipments will travel in the ground itself. All the military equipments are movable equipments. That's the beauty. All the equipments, all will be gigantic. All the equipments are movable in the ground. So if you are interested, just search in the internet. We can see plenty of photos regarding those equipments. In these equipments only, we are trying for IoT. IoT application Opencast Mines. What is the challenges we face? If we googled, if you search in the internet Opencast Mines pictures, we will surprise. The reason is, as I said earlier, the mine size will be enormously big, right? So especially in SME based in mines, human beings will be very minimum. Human movement, we can't see the human movement inside the mines. Very minimum people will be engaged in these areas. So human movement will be very minimum. So in those areas, the major problem is having the network, internet connections. So our main thing is we need internet. Without internet, we can't go for IoT projects. But because of the vast area, as we seen in our poster, where we can keep the cell phone towers in the outside area only, we can fix our towers. As I said, length of the mines will be more than 6 kilometers. Width will be around 6 kilometers. In such a biggest area, and also there is no human number of human beings involved in the mining, also very minimum. How it will be economical to keep towers outside the mines? And how we will get the internet connection inside the mines? That is a major question in front of us. Getting the signal inside the mines is a tough. Then next thing. So okay, we'll arrange for that. If we arrange for that, then the next problem in front of us is, when we are talking about mines, many mines were started very long back. We are having our tradition from 1960s. We are having mining equipments, which were bought nearly 1960s. In 1960s, if I said I want a data connectivity facility, means where I can go. All the equipments are electrically operated equipments. So all SME equipments, okay. But controller design is contact logic systems. In contact logic systems, if I said I want data connectivity facility, how I can get? That is a major problem in front of us. So if I am opening a new mines, if I am purchasing a new equipments, those equipments can be provided with the data connectivity facility. But if I am handling with the mines, which is already having a lot of equipments, in those mines, the data connectivity facility is the toughest thing. For this one of the easiest solution is predominantly in the project, what we got convinced and concluded ourselves, instead of controlling equipments, we somewhat struggled to control the equipment. So we gone for monitoring the equipments, right? So for monitoring the equipments, so we can put some simple PLC based devices. Those devices, they won't go and control the equipments. Just they will monitor the status. For example, from a machine, if I want to observe, for example, 100 parameters, 100 values, 100 parameters. Okay. Then I can connect the 100 values to the PLC device. That PLC device will send the values to the through internet to the IoT. That is one of the easiest way to overcome the issue. So we can go for some simple PLCs. Those PLC only will monitor. They won't control the equipment. If you want to control the equipment, then you need to totally wipe it off the control logic system. You need to implement. You need to adopt the PLC system. Then it will be very costly to execute the IoT project. So second thing. So yes, sir, already I am having some data connectivity facility. Right, well and good. When it was purchased, that matters. For example, if we purchase those equipments by around 2000, so those times where we have digital equipments, right? Well and good. Even PLCs also we have substituted PLC by 2000 also. But the problem is, what is the protocol available in the digital equipments? Predominantly, if we go for IoT projects, the IoT cloud boxes will communicate in TCP/IP protocol, right? So those are the digital equipments. The equipments what we have, those equipments should have TCP/IP protocol connection facility. If it is not having, then once again it will be a costlier issue. So if we are having a PLC like this, PLC CPU like this is called MPI port. This is called our RJ45 jack port. So this RJ45 jack port can be used for a TCP/IP protocol. Well and good, nice. But normally, if you purchase a PLC which is not meant for this type of cloud communication, then it will have only MPI ports, right? Next, sir, if I am having only PLC systems, that is not having any RJ45 port, right? Well and good. If it's so, in such a case, what may be a solution? There is no need to replace the CPU. We can go for some CPs, communication process. We can go for some communication process. That communication process will support us. But still we have some more problem. All these things are cost impact. It will have some cost impact. Communication process will be somewhat costlier. Even though if we purchase communication process, we need to purchase in some of the brands. In some of the brands, even though this port is available, even though the port is capable of communicating TCP/IP, we need to buy license. We need to buy license. Then only those processes can communicate with the IoT device. So that's why it will have some cost implications when we are going for old systems to introduce IoT. So these things also we need to keep in our mind. Not only purchasing of cloud box and web design is not only the matter, we need to think about these areas also. Then communication. Regarding communication in mines, already as we discussed, mines is a vast area. Then line of sight also issue also will be there. Then handling of the equipments. For example, if we want to make communication, effective communication inside the mines, then somewhere we will prefer fiber optics. But while handling the equipments, the fiber optics may get damaged easily. That too also possible. The mines equipments are not fixed locations. They are always movable. Mines itself, it is a movable thing. So in such a case, where if we made a once line of sight, doesn't mean that for next 20 years the same line of sight will be maintained. Or next 10 years, minimum not for next 1 year. Within 15 to 30 days, the line of sight may be lost. So we need to maintain the line of sight. Handling issues we have, vast areas, so signal availability will be tough. Some mines movement also it is there. So these are the areas we have problem in the mines. So and also it will be in the deeper part. Your towers are in the higher altitude. So your antenna radiation pattern, that too also matters. Whether it will reach the bottom part of the mines. So for that one, we need to know aware of the radiation pattern of the antennas. So in these projects, if you are using your own communication systems, your own communication networks inside the mines, you can go for patch antennas like this one. We can go for omnidirectional antennas also. So if you are having a PLC, as we discussed previously, by using a communication processor, by using a radio modem, by using an antenna, we can bring the signal out, right? So next thing is antennas. Regarding antennas, omnidirectional antenna, the radiation patterns and front elevation pattern will be something like this. In azimuth angle, there is top view, it will like this. In 360 degree, it will radiate the pattern. But the problem is, for distance will be little bit lesser. So for movable equipments, we can use omnidirectional antennas. For fixed equipments like conveyors, movable equipments, bucket wheel excavators, MTs, mobile transfer conveyors, spreaders, or movable equipments. For those equipments, we can use omnidirectional antennas. For conveyors, for they are fixed. For next 15 to 30 days, it will be fixed location. For those things, we can go for patch antennas. So patch antenna, radiation pattern, we should be aware of all these things. That is how the antennas radiation pattern will be. The elevation pattern also somewhat will look like the same way. So in one direction only, it will radiate the pattern, radiate the signal. Elevation pattern also will look like somewhat similar like this, right? It is not visible in this one. So when we are going for, instead of using the third party network signals, if we are going for our own network signals, means then what we supposed to do? So one control room will be there. So locally we'll keep some local antennas. All the equipments will connect with the antenna, right? So we can have some bucket wheel, MTC, dry heads, then spreaders. So all the equipment will communicate with the local antenna. From the local antenna, we will get the signal. It will go to control room, because control room will be kept far away from the mines in the sophisticated area. So that's why this is the idea for making the communication. Okay, next. So how will be the mines? So this is one of the conveyor. Right? DH1 is the conveyors, DH2 is the second conveyor, DH3 is the third conveyor, DH4 is the fourth conveyor, DH5 is the fifth conveyor. So we have conveyors, we have bucket wheel and MTCs, we have spreaders. Bucket wheel will cut the soil, it will load in the conveyor, it will be transferred through the conveyor, it will be dumped in the by spreader in the dumping side. So material will be transferred from cutting side to dumping side. So overburdens can be transferred in the same way. If you want lignite or any other ore, it will be kept away and will be dumped in the dumping yard some far away from this area. Okay. So same way, this is a top view of the mines. Here we are having front view also, that is the cut side view also, sectional view also, cutting face, and we have cutting face and the dumping side, both are available now. The second thing, one bench. So if the bucket excavator is moving like this in this space, it will move in this area, dumping will spreader will move in this area. So in the soil which is available in this area, it will be dumped in this one. So it will form a bench. So one bench is formed in sectional view, one bench is formed. Okay, this is a cutting area, the soil will be dumped in this area. Like that, we can have minimum six benches will be there. So third bench, fourth bench. So something like a pond, steps. So these are the cutting stage. Here one conveyor will be there, one system of conveyors. Here second system of conveyor. Here third system of conveyor. Here fourth system of conveyors. So 4 to 6 conveyor systems will be there. So each one is called, the blue color one is called one bench, red color one is called one bench, green color one is called one bench. Like that, everything will make it one bench systems. So okay, now we are seeing only one bench equipments. So this is our conveyor. The black color line is our conveyor. So this is our cutting phase. The cutting phase we are having bucket excavator and MTC. This is communicating with the local antenna. The local antenna is communicating with the control room. Then here we are having driver. This driver is communicating with the local antenna. So driver 2, driver 3, driver 4, then spreader. Everything is communicating with the local antenna. If there is any line of sight issue, we will make some other arrangement in the pattern. But the problem what we face, many times we are unable to meet in the link. Frequently link failure was there. These things were done during 2008 to 2013. By 2013, I think we all know that by around 2013, 2G internet connection started to come into market. That time IoT concept started to come into market. So we tried for IoT projects, how it will be. So since we had a lot of problems in the networking, frequently a link will be failed. So that's why we started to think about is it possible to go for IoTs, internet connections? So, for IoT, what is the basic hardware component for IoT? A cloud box will come, nothing else. There is no need to modify huge. There will be a cloud box will come. That cloud box needs to be connected with the PLC through this RJ45 port. Remaining things subject to your device is having data connectivity facility. All the data is available with the CPU. In such a case, just if you plug a cable and a cloud box, then it will be sufficient. Then in addition to this, we need to do a lot of programming to move the data from PLC to cloud box. Okay, after sending the data to cloud box, it will go to server room. In server room, it will be processed. As we discussed previously, it will be processed. Web pages will be created. In web pages, it will be shown. So whenever people want, we can see the things. That is possible. So we are having a bench is having bucket wheel, MTC, dragger, and spreaders. So all the equipments are having cloud box. So this bench one will make a system. Second, bench 2 will make a second system. Bench 3 will make a system. As we discussed previously, systems of systems combining together, making intelligent systems. So that is the thing happening now. So now we are connecting all the benches to our server room. From server room, end user getting the information. Well and good. So we are having all the information. Well and good. So for example, if a mines is having only 3 benches, if I am combining 2, 3, 4, 5 mines together, then it will become intelligent systems, more and more intelligent systems. For example, any one of the mines or any one bench got having some maintenance issue, that's why production is not there. Immediately that information will be transferred to another mines of the same owner, then he can start to produce more. That too also possible. Live monitoring of production, that is possible. If we go for cloud-based systems, so in cloud-based systems, the screens will be something like this one. So on this screen, we are having a conveyor. Conveyor is represented like this one. Bracket 1, this is a complete conveyor. If it is a green, indirectly shows that the system is running. Here, the green indirectly shows that system is ready for operate. The second conveyor also running. It is also healthy. The same way, here we are having a spreader. The spreader also healthy. It is also running. The bucket wheel also healthy. It is running. Actually, exactly speaking, in mines, if any one of the system got stopped, for the in charge finding where it got stopped, that is the toughest task. He needs to call one by one all the people where it got stopped, because the system length will be coming around 8 kilometers of length. So where it got stopped, why it got stopped, who stopped those missions. Understanding these things will take new half an hour. The production loss involved on all these things. So that's why people are giving more importance to IoT, to understand this, why it got stopped. If I ask, I come to know that if the system got red, it indirectly shows that the system is idle, it is stopped. Okay. In this case, why it got stopped? I can have another screen. In the screen, it will show that belt slip got acted. Because of belt slip, the system got stopped. Things will be available as a web page. From the web page, I can get all the informations, right? Not only instantaneous things. In addition to this, we can record graphical values also. So for example, yesterday in which shift production was excellent. If I want to know, I can check. If a conveyor got tripped due to overload, why it got overload, whether it is average load is same, whether the loading pattern is same. If I want to check all these things, if I am having IoT, it is possible to check the loading pattern too. So the people's attitude of loading. So all these things we can check by using the recorders available through the IoT. That too also possible. Predictive maintenance also possible by using IoT, right? What are the other areas of Opencast Mines? Means Opencast Mines predominantly the street lighting purposes we are using. In addition to this, pontoons. That is, in mines means the water seepage will be very heavy. It will be collected in the bottommost part of the mines. Then it will be pumped out of the mines, right? That is called the pontoons. In the pontoon areas, the controlling of there is monitoring of pontoons. There is water level, running condition, energy consumption. All these things can be monitored through IoT. That too also possible in mines. The issues with the IoT. As of now, the present issue with the IoT is the signal loss. Some of the times, my experiences, even for 20 minutes, the signal was not available. For example, if I want to see the present status of my machine, immediately I am getting into my login, I am seeing the status of a machine. I 200% I can't assure that it will be readily available for me, because if the signal is healthy, it will be available. Before a execution of the project, we will do a lot of signal survey. That is, communication people, they will do a lot of signal survey also. After signal survey only, we will select the SIM cards, we will put antennas and all those things we will do. But any one of the nearby third-party tower got failed. In such a case, we are depending on the service provider only. So if the service provider's tower got failed, immediately our SIM cards will switch out to some another tower which is near to this. But in such a case, that tower, it will get crowded up. So traffic will be more in the tower. So the link availability for my machine will be least. I can't expect once in a machine. Actually, theoretically, it is possible to communicate once in a second. But if we are going for TCP/IP, it can be once in 30 seconds also possible. But even if we can't get once in a minute, that too also tough in this field. As of now, we are facing the problem. So nearly even it will go up to 20 minutes. So that's why reliability point of view, we have some issue. We come across some practical difficulty in this. So some of the solutions, what we can expect in this. So 5G, some of them are having opinion on 5G, but my personalized opinion is I am expecting M2M concepts. That is a mission to mission communication SIM cards. Now itself in the market, many of the service providers are giving M2M SIM cards. There are some special type SIM cards. The SIM cards can be used only for data communication, not for voice communications. So in such a case, those service providers are giving more importance to the SIM cards for data connectivity facility. If the service providers point of view, if this thing, that is link facility, that is preference to the machines are increased, if we are able to get signals once in 30 seconds or once in a second, then the trend will be changed enormously in this field. Thank you very much. We'll wait for some questions, please. Sir, shall we stop now?
Yes, sir. Yeah, we can stop, sir. We can give the conclude marks and we can stop.
Thank you very much, sir. Thank you for the session watching. Thank you.